Flappy Bird is the perfect first game. One input. One mechanic. And it is the smartest way to learn Godot from absolute zero. In the next 20 minutes we build the whole thing together, no experience needed. Quick, honest heads up before we open the editor. If this is your very first game, the thing you will want next is a plan. So I made a game dev starter kit, $19, with a 30-day roadmap for exactly what to build after Flappy Bird. It is completely optional. The link is below. Now, let's build. Here is exactly what we are building. A bird that falls under gravity. A tap that makes it flap upward. Pipes that scroll in from the right with a gap to fly through. A score that ticks up, and a game over screen that restarts on the next tap. That is the entire game. Godot is a free, open-source engine, and this is Godot 4. One quick note before we start. Godot's editor is a desktop app, so instead of tiny screen recordings, I am going to show you clean node trees and real, correct Godot 4 code. Every hands-on click is in the written guide on screen, follow along there for the exact screenshots. Let's set up the project. Create a new Godot 4 project, and add a 2D scene as your main scene. Rename its root node to main. This main node is the stage, everything else lives under it. Under main we will build a small tree. A background sprite. The bird. A node called pipes to hold the pipes we spawn. A timer to spawn them. And a canvas layer for the score and the game over text. Two words you will hear constantly, nodes and scenes. A node is a single building block. A sprite is a node, a timer is a node, a collision shape is a node. A scene is just a group of nodes saved together, like our bird or our pipe. Your whole game is a tree of nodes, and Godot calls that the scene tree. Do not worry about wiring it all yet. We add each piece as we reach it. The shape of the tree is the mental model, hold on to it, and the code will make sense. Let's make the bird. In the Godot editor you add a character body 2D node, and name it bird. A character body 2D is Godot's node for something you move with code, perfect for a player you control. Give the bird two children. A sprite 2D for the picture, and a collision shape 2D so it can hit things. In the editor you drag your bird image onto the sprite and size the collision box to match. The written guide has the exact screenshots for that part. Now the fun part, the code. Attach a script to the bird. Here it is, and it is genuinely this short. At the top, extends character body 2D, this script is a bird. Then two constants. Gravity, a positive number that pulls the bird down every frame. And flap, a negative number, because in Godot, up is negative on the y-axis. The whole behavior lives in physics process, which Godot runs at a fixed rate, every physics frame. Line 1, velocity.y plus equals gravity times delta. That accelerates the bird downward, smoothly, no matter the frame rate. Multiplying by delta is what keeps it frame rate independent. Next, if input that is action just pressed, flap, set velocity.y to the flap force. Just pressed fires once per tap, not while held, that is exactly the Flappy Bird feel. One tap, one flap. Finally, move and slide. In Godot 4 you call it with no arguments, the node already has a velocity property, and this line applies it. That is a big change from Godot 3, where you passed velocity in. If you find an old tutorial doing that, this is why your code breaks. One more thing about physics process versus the regular process function. Physics process runs at a fixed 60 times a second, no matter your frame rate. That makes movement consistent on every machine, which is exactly what you want for gravity. 3 real lines of logic. Press play, and your bird falls, and taps to rise. You already have the beating heart of the game. Now the obstacles, the pipes. A pipe is its own little scene, so we can spawn as many copies as we want. This is the single most important idea in Godot. Build a thing once as a scene, then instance it over and over. Create a new scene with a node 2D root, and call it pipe. Give it a top pipe and a bottom pipe, with a gap between them. Each pipe is a static body 2D with a sprite 2D and a collision shape 2D, static, because the pipe does not move under physics, we move it ourselves. Between them, add one more node, an area 2D called score zone, sitting in the gap. An area 2D does not block anything. It just notices when the bird passes through it, that is how we will score a point. Save this as pipe.tscn. Here is the pipe script. Extends node 2D. A speed constant. And process, which runs every rendered frame. Position.x minus equals speed times delta, that slides the pipe leftward across the screen, again scaled by delta so it moves at a steady pace. Then a cleanup check. If position.x is less than minus 100, the pipe has gone off the left edge, so Q-free removes it. Without that line, old pipes pile up forever and slowly eat your memory. Small habit, big difference. Why build the pipe as its own scene at all? Because a scene is a reusable template. Save it once, and you can stamp out 100 copies at runtime, each one independent. Change the pipe scene later and every copy updates. That is the instancing pattern, and you will lean on it in every project you ever make. So one pipe scene knows how to slide itself left and clean itself up. Now we just need to keep making them. Time to spawn pipes on a timer. Back in the main scene, select that timer node we planned. Set its wait time to about 1.5 seconds, and turn on autostart so it fires the moment the game begins. We need main to know about the pipe scene. At the top of main script, an exported variable, pipe scene, of type packed scene. Export means it shows up in the editor's inspector, and you drag your pipe.tscn right onto it. No file paths in code. Now connect the timer's timeout signal to main. Signals are how Godot nodes talk to each other, the timer shouts timeout, and our function listens. In the editor you click the timer, open the node panel, and connect timeout. The guide shows precisely where. Here is the spawn function. First, pipe scene.instantiate. That is the line that turns the scene into a real, live copy in the game. Then we set the new pipe's position. X is off the right edge, at 700. And for Y, randf range gives a random height each time, so the gap moves around and the game stays interesting. Finally, add child adds the pipe into the running scene, and it immediately starts sliding left thanks to the script we already wrote. Notice how little code this is. The timer handles the when. Instantiate handles the copy. The pipe's own script handles the movement. Each piece does one job, that separation is what keeps a game readable as it grows. Press play now, and pipes march in from the right, forever, every 1.5 seconds. It is starting to feel like a real game. Let's count the score. Remember that score zone area 2D sitting in the gap between each pipe. When the bird flies through it, it should award 1 point. First, the display. Under the canvas layer, add a label and call it score label. A canvas layer keeps the text pinned to the screen, so it never scrolls away with the pipes. Set the font nice and big in the inspector, and start its text at 0. In main script, a score variable starting at 0, and a small function, add point. It bumps the score by 1, then updates the label. str converts the number into text, because a label shows text, not raw numbers. Now the wiring. On the pipe score zone, connect its body entered signal. When the bird's body enters the zone, it calls back to main and runs add point. 1 pass through the gap, 1 point. The label updates instantly on screen. That is the entire scoring system, a zone, a signal, and a counter. No physics tricks, no distance math. This signal and node pattern is how almost everything in Godot is built, and you just used it for real. Here is why signals matter so much. The pipe does not need to know what a score is. It just shouts, "Body entered." Main decides what that means. That loose coupling keeps your nodes independent, so you can reuse them anywhere. Now the part that makes it a game, losing. Right now the bird can smack a pipe and nothing happens. Let's fix that, and add the restart. Give the bird one more child, an area 2D called hitbox, with its own collision shape. At the top of the bird's script, declare a signal, died. Then connect the hitbox's body entered signal, and in that function, emit died. So the moment the bird touches a pipe, it announces it is done. Over in main, listen for that died signal from the bird. When it fires, we run game over. Get tree, paused, equals true, that freezes the whole game instantly. Then we reveal a game over label we tucked into the canvas layer. The player sees the crash and the message. And the restart. In main, add unhandled input. If the game is paused and the player presses flap again, we call getTree, reload current scene. That one line rebuilds the entire level from scratch, fresh bird, no pipes, score back to 0. Tap to die, tap to try again. That loop is the whole addictive heart of Flappy Bird. Why pause the tree instead of deleting things by hand? Because paused freezes every node at once, pipes stop, the bird stops, the timer stops. Nothing keeps moving behind the game over screen. Then reload current scene gives you a guaranteed clean slate. No leftover pipes, no stale score, no bugs from half reset state. Take a breath, because that is a complete, playable game. Gravity, flap, scrolling pipes, scoring, death, and restart. From an empty project. Let's make it feel finished. Polish is what separates a tutorial project from something you are proud to share, and none of it is hard. Add sound. Drop an audio stream player on the bird, and play a little blip in the flap code. A second one for the crash. Instant game feel, your ears sell the action. Add a scrolling background with a parallax background node, so the world drifts past behind the bird. Then tune the numbers. Nudge gravity, the flap force, the gap size, and the pipe speed until it feels fair but tense. That tuning is real game design, trust your hands. One more habit for later. Save the high score to a file with Godot's file access, so your best run survives a restart. It is a few lines, and it teaches you how saving works, which you will use in every game after this. Want more juice? 2 quick wins. Add a small particle burst when the bird dies, using a GPU particles 2D node, a cheap effect that reads as expensive. And a tiny screen shake on impact, by nudging the camera for a few frames. Players feel those touches even when they cannot name them. And give it a start screen. A simple menu scene with a play button, loaded first, makes the whole thing feel like a finished product instead of a demo. It is the same reload scene trick you already know. That is the polish pass. Same tiny game, but now it looks and sounds like the real thing. And that is Flappy Bird, in Godot 4, built from nothing. You now know nodes, scenes, signals, gravity, spawning, scoring, and restart, the exact toolkit behind almost every 2D game. Here is your next move. Do not stop while it is fresh. Your next watch is lined up, a Godot 4 state machine, the pattern that powers clean player controllers and enemy AI. And if you want a full map, the GameDev Starter Kit's 30-day roadmap tells you what to build after Flappy Bird. Link below. Subscribe for more beginner Godot builds. Now go make the bird flap. See you in the next one.